At 15 seconds, guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
Shadow. 4 forward, drift into the right a little. 30 seconds. Forward, drift. Contact light. Okay, engine stop. Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're going to be busy for a minute.
Armstrong is on the moon. Neil Armstrong, 38-year-old American, standing on the surface of the moon. On this July 20th, 1969.
That's one small step for man. One giant leap for mankind. Oh, that looks beautiful from there, Neil. It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here. Beautiful, beautiful. Isn't that something? Magnificent sight out here. Magnificent desolation.
Tranquility Base, Houston. Guidance recommendation is pings, and you're cleared for takeoff.
Roger, understand. We're number 1 on the runway. 7, 6, 5, engine arm ascent. Beautiful. Very smooth. Very quiet ride.
Apollo 11, this is Hornet, over.
Apollo 1, this is Apollo 11, reading the loud and core. Our position 1330.
On July 16, 1969, astronauts Neil Armstrong, Edwin Aldrin, and Michael Collins boarded the Apollo 11 command module and launched from Cape Canaveral, Florida, on a mission to be the first men to land on the moon. Their successful landing on July 20th was watched on televisions around the world. Armstrong's first words after setting foot on the moon have become a part of history.
The Eagle has landed. That's one small step for man, one giant leap for mankind.
While on the lunar surface, Armstrong and Aldrin collected samples of the moon to be analyzed when they returned safely to Earth. They spent a total of 21 hours on the moon before rejoining Collins orbiting overhead. They returned to Earth as heroes on July 24th, forever immortalized by their actions. The successful lunar landing was the pinnacle moment of the space race between the United States and the Soviet Union.
We can't see the Apollo lunar landing sites from the Earth, but we can see them from orbit around the moon. I'm Amy Shearer Title, and this week on Vintage Space, we're talking about the Apollo lunar landing sites. It's the conspiracy theorist refrain and something that came up in my video about dust being proof of the lunar landings. If we really did land on the moon, can't we just turn a really powerful telescope to the moon's surface and look at the landing sites? Well, no, we don't have telescopes that powerful, and even NASA's Hubble Space Telescope can't resolve the lunar landing sites. Hubble can only resolve features as small as about 280 feet across on the moon's surface, so there's no way it could see the descent stages left on the moon. The landing gear spans less than 30 feet across. But NASA's Lunar Reconnaissance Orbiter can see the landing sites, and we can compare the images captured by this spacecraft to maps NASA released in the 1960s and 1970s that show the astronauts' traverses around the moon. Like Apollo 11. This first and most famous moon landing was NASA's most conservative mission. Neil Armstrong and Buzz Aldrin spent about 20 hours on the moon, just 2.5 hours of which they spent walking around. They set up a TV camera and flag north and slightly west of the Eagle's landing site. They set up some surface experiments south of the lander, and the furthest they traveled was to a crater to the east of their landing site. They just visited its western edge. This image from the Lunar Reconnaissance Orbiter lines up with the map NASA released in the Apollo 11 post-mission report in 1969. We can see the lunar module's descent stage, the disturbed regolith north of the lander where they set up the camera and flag, which was knocked over when they launched from the moon's surface, the footsteps leading south to where they set up their surface experiments, and the path they took to the crater east of the landing site. We can compare these traverse maps to orbital photography for all the Apollo missions, and it's pretty awesome that the maps NASA released following the astronauts around the moon line up exactly with what we're seeing from orbit today.
Third-party evidence for Apollo moon landings is evidence or analysis of evidence about moon landings that does not come from either NASA or the US government or the Apollo moon landing hoax theorists. This evidence serves as independent confirmation of NASA's account of the moon landings. In this section are only those observations that are completely independent of NASA. No NASA facilities were used, and there was no NASA funding. Each of the countries mentioned in this section has its own space program, builds its own space probes which are launched on their own launch vehicles, and has its own deep space communication network. In 2008, the Japan Aerospace Exploration Agency Selene lunar probe obtained several photographs showing evidence of moon landings. On the left are two photos taken on the lunar surface by the Apollo 15 astronauts August 2, 1971, during EVA 3 at Station 9 near Hadley Rill. On the right is a 2008 reconstruction from images taken by the Selene terrain camera and 3D projected to the same vantage point as the surface photos. The terrain is a close match within the Selene camera resolution of 10 meters. The light-colored area of blown lunar surface dust created by the lunar module engine blast at the Apollo 15 landing site was photographed and confirmed by comparative analysis of photographs in May 2008. They correspond well to photographs taken from the Apollo 15 command/surface module showing a change in surface reflectivity due to the plume. This was the first visible trace of manned landings on the moon seen from space since the close of the Apollo program.
It's time for the Longines Chronoscope, a television journal of the important issues of the hour.
Good evening, this is Frank Knight. May I introduce our co-editors for this edition of the Longines Chronoscope? They are CBS News correspondents Larry Lasser and Lou Chaffee. Our distinguished guest for this evening is Milton Rosen, head of rocket development for Naval Research Laboratories in Washington.
You've often heard it said that science has far outdistanced man's political and social development. But because of the mystery that surrounds science, one has a feeling that tremendous developments are in the offing which might catch us unawares. And one of those mysteries, of course, surrounds the space rocket. Mr. Rosen, as head of the development of the space rocket, you've shot a rocket higher than any other man has done. Now, do you think men will soon be liberated from the bonds of Earth and travel around in space?
Well, Mr. Lasser, I think they will be liberated, as you say, eventually. How soon, I do not know.
Well, how will this come about? Will man go up in a rocket, or can that be done now?
Well, I think that first we will explore with instruments. At the present time, rockets have gone up almost to 200 miles, but men have only gone up to about 15 miles. And the same story will be repeated in outer space. First, instruments will be sent up in satellites, later men, and so on with the exploration of the moon and other planets.
Now, that model of a rocket that is on the desk there, is that the famous Navy Viking, which you've shot off, the single-stage rocket?
Yes, that's a model of a Viking.
And that is not for military use, but for exploration in space, is it?
Yes, it's devoted to upper atmosphere research. The nose and a good part of the rocket is packed full of instruments to study the sun, to determine the pressure, composition of the atmosphere, to study cosmic rays, to study the ionosphere, all the things that interest scientists.
Mr. Rosen, you talk about rockets. What is the difference between a rocket and a guided missile and a jet? These terms we hear so frequently.
Well, guided missile is probably the broadest term, and there are rocket-guided missiles and jet-guided missiles. The jet, as used in jet aircraft, is really an air-breathing engine. It's an engine that operates within the Earth's atmosphere and therefore would always fly relatively close to the Earth's surface. A rocket, however, doesn't need air from the atmosphere. It carries its own oxygen, and it can operate outside the atmosphere, and therefore it is the type of vehicle, the type of propulsion that will eventually be used in outer space.
Mr. Rosen, you said that you couldn't say how soon men would be traveling in space, but do you think that the generation which is now watching space travel on TV will go out into space in their lifetime?
Well, it's hard to say. I think they'll see a tremendous advance, and a lot of this depends on how hard we work at it. I feel it's inevitable, and that our youngsters will see a lot more than we have.
Mr. Rosen, I'm searching for definition tonight. What is a satellite?
A satellite is a vehicle that orbits or circles around the Earth continuously. The satellites that have been spoken about recently, instrumented satellites that are being studied, would say travel about 1,000 miles above the surface of the Earth. And therefore they would complete an orbit or circuit around the Earth in about 2 hours.
In other words, if you shot a rocket outside of the Earth's gravitational pull and not into the gravitational pull of another planet, it would stay there and travel around the Earth as one of our satellites?
Well, any satellite would be almost entirely under the influence of the Earth, and the pulls of the other planets would be so minute that they wouldn't matter. The pull of the moon would probably be more important to a satellite about the Earth.
Well, if you think space travel, and I think that implies that human beings would be traveling, is not in the foreseeable future, nevertheless, how about this idea of shooting a rocket so high that it would go out of the Earth's gravitational pull and become a satellite? Is that in the foreseeable future?
Oh, yes. I think such a vehicle is within our grasp now, and that if a concerted effort were made, that we could in very short time have an instrumented satellite circling around the Earth.
Well, do you think it would be any great advantage or any possible danger to the rest of the world if one nation or another did build a satellite or a platform perhaps that was circling the Earth and could watch the rest of the world go by from their advantageous position?
Well, I don't think there would be any danger. The possible military use of a satellite has been greatly overrated, and even this point that you raise of watching other people is going to be very difficult. The first satellites will be used mainly for scientific experiments and collecting data about the region, studying cosmic rays.
Now, how exactly would you get such a satellite up above the Earth?
Well, it would be a rocket, and as most people have said, it would probably be a three-stage rocket, starting with a large rocket, which then pushes a smaller rocket, the middle rocket, to a high altitude, and then this one takes over, and finally the third or last rocket would have enough speed to climb into an orbit and stay there.
Do you think it would be possible at any point to station men up there to have like a kind of a roving city circling the Earth?
Well, this is a great distance away from an instrumented satellite, and the practical problems of getting any large amount of material up to a satellite orbit are the things that make it very difficult.
Are these what you are learning about now in these shoots from Sandia Air Base and White Sands? And the shooting of your Viking rocket, is that what you're learning about now, the difficulties of transporting men up to outer space?
No, not necessarily men. We're learning about the difficulties of operating rockets and the difficulties of making equipment work, but we learn enough about that to show us how difficult it would be to maintain a man up there, to maintain all the equipment necessary to give him air, to keep him from freezing or roasting, to protect them against cosmic rays and radiation, to protect them against weightlessness.
See, Mr. Rosen, would you think you'd have any difficulties in getting volunteers to go up in a rocket even now?
I doubt it. A lot of people have volunteered to go up.
Then why don't you send a man up there then?
Well, we see little useful purpose in doing it. So much effort would have to be expended on protecting that one man that we could more profitably send instruments to do the work.
And these instruments do tell you what is taking place in the upper atmosphere at the moment, as well as a man could?
Probably better, because you can do a variety of things with instruments. A man cannot count cosmic rays, but a Geiger counter can.
Mr. Rosen, what is the difference between your research rocket and the rockets used for military purposes as weapons?
They are usually more rugged, whereas our rocket is built primarily for efficiency to reach very high altitudes. Also, the Viking isn't built particularly to hit any target. Its object is to reach the highest altitude and to send back information to the ground by radio.
Mr. Rosen, what is the most difficult problem you have to overcome in we'll say, going to the moon?
Well, that's a hard question to answer. I think we're faced with a multitude of problems, all of which have practical difficulties. In theory, none of these problems are really very difficult. It's when you have to build something to do the job that you run into a lot of practical trouble.
Well, Mr. Rosen, one question I would like answered is, why go to the moon at all? What practical benefits can we get from going to the moon?
Well, it's very hard to say. There are certainly people who will see benefit just in the exploration. The benefit to science, I think there's a lot to be said for discovery, finding out new things. After all, the upper atmosphere is now the last earthly frontier. If we want to discover new regions, we have to go away from the Earth.
I say, Mr. Rosen, you're a member of the American Rocket Society. Do you think it would be worthwhile, do you enthusiasts think it would be worthwhile to start a crash program like the one we employed to build the atom bomb in order to build a rocket that would go to the moon?
As much as many of us would like to see such a program, if we do any wishful thinking, I think we should take a more gradual approach. I think we should concentrate on instrumented rockets, on learning more about the problems before we attempt any big program for, say, the exploration of the moon.
Mr. Rosen, the fact that you are a space expert leads me to a question I think I have time for. That's the question about flying saucers. There have been reports that they've been seeing some sort of objects in the sky in Italy now. Now, as a space expert, do you think there's anything in these flying saucer stories?
Well, I think the people are seeing something. What it is, I don't know. And there have been many explanations, any one of which I think might be plausible. One of the explanations, of course, is that these saucers are visitors from outer space. Until there is some tangible proof of that, I can't accept that as the final explanation.
I see, but you do think there is something to it. Well, I want to thank you very much for being so interesting, answering so many questions tonight, Mr. Rosen. Thank you.
The opinions expressed on the Longines Chronoscope were those of the speakers. The editorial board for this edition of the Longines Chronoscope was Larry Lasser and Lou Chaffee. Our distinguished guest was Milton Rosen, head of rocket development for Naval Research Laboratories in Washington. To give a Longines watch this Christmas is to give just about the finest watch made anywhere in the whole world, and yet, unbelievably, a Longines watch is not costly. There are many outstanding Longines watches perfect for Christmas giving, priced as low as $71.50. Longines ladies' watches are superb examples of the jeweler's art. Exclusive in style, exquisite in taste and finish, incomparable in timekeeping. There's a model for every taste and for every occasion. The variety of Longines watches for men is equally extensive. There are watches for dress and sport. Longines automatic watches, the most advanced in the world. Longines waterproof and shock-resistant watches for rugged service. Longines chronograph watches for sportsmen and scientists. And every Longines watch, whether for a lady or for a gentleman, is made to the unique standards of excellence which have won for Longines 10 World's Fair Grand Prizes, 28 gold medals, highest honors for accuracy in fields of precise timing. Yes, to give a Longines watch this Christmas is to give just about the finest watch made anywhere in the world. And yet, we repeat, you may buy and proudly give a Longines watch this Christmas for as little as $71.50. Longines, the world's most honored watch, the world's most honored Christmas gift. Premier product of the Longines Whitnor Watch Company since 1866, maker of watches of the highest character. We invite you to join us every Monday, Wednesday, and Friday evening at this same time for the Longines Chronoscope, a television journal of the important issues of the hour, broadcast on behalf of Longines, the world's most honored watch, and Whitnor, distinguished companion to the world-honored Longines. This is Frank Knight, reminding you that Longines and Whitnor watches are sold and serviced from coast to coast by more than 4,000 leading jewelers who proudly display this emblem, Agency for Longines Whitnor Watches.